We've been looking at similar triangles for the last couple times of notes, and now we're gonna actually solve for the missing parts on our triangles. And again, the thing to stress to you is that corresponding sides of similar figures are proportional. So we're going to have to set up the actual proportions. And we did a little bit of that in our last notes. Using the scale factor to find the missing sides of the similar figures. Corresponding angles of similar triangles, again, they are congruent. They're going to be the same value. So if we need to find an angle, then we're going to set them equal to each other. But we're going to look at more of the algebraic side today of similar triangles. And I want to stress the reading of this. It says triangle DFE is similar to ACB. So we don't have the primes in there, and that's causing a few people some trouble. So, kind of say it to yourself as you're reading it, that it's the bottom triangle is similar to the top triangle. Although the fact that we know that both of them are similar is really ultimately what we need. But I'm going to go in that order. And I want to stress to you once again that when we're looking at this to find the missing sides of the triangle, DF is the first two letters in our first triangle, and DF has a length of 14. So comparing that here, in our other triangle, AC are our first two letters. AC has a length of 7. We also see that DE has a value of 20. So that's the first triangle. So we're comparing it here in our next triangle to figure out, well, again, DE is the first and the third letter. So the first and the third letter in our second triangle is AB. We're going to be finding out the length of AB. And if you don't want to write AB there, put some variable in there. Put an X in there. Put an A in there. Put an N in there. Whatever works for you. But that's the length that we're finding on this first part of this problem here, because it says find the missing sides. And there's a proportion. And we can solve it. We solve it by cross multiplying. So we get 14 times AB equals 7 times 20. And oftentimes what I do is I just divide both sides by 14 and get the length of 10, I think it is. But if you're not sure, you can do 7 times 20 divided by 14, and we get the 10. You don't even need a fraction button or anything on there to do that problem. So we know now that this length is 10, and we want to find one more side length. We want to find this side length of FE. The nice part about this problem is we already know 14 over 7. We don't have to set that up again. We've got a complete fraction there. We don't have any missing parts. And now again, what we're trying to find is we're trying to find the value of FE, which is in our bottom triangle. And in terms of the list, FE is the second and the third letters listed in a triangle. So we're going to put the second and the third list in our second triangle, which is CB, and it has a length of 8. And then we're going to cross multiply. Cross multiply. 14 times 8 equals 7 FE. And divide both sides by 7. And again, we can use Desmos, we can use our calculator to figure it out. I think the answer is 16, but let's check. 14 times 8 divided by 7 is 16. And we found the missing sides. Number 2. As in the diagram below, ABC is similar to DCE. We want to watch out for the side lengths. And again, I look at those side lengths. Sometimes I use tick marks because in particular here on this one of the things that I do know is that this angle and this angle right there are vertical angles. So there's a relationship between AB and ED or DE, but we know that from the list of the triangles as well. So we want to set up a proportion, and in fact, I'm going to go in order. AC on our picture here is 6. DC on our picture is X. If we go to CB on our picture, CB is 5. And CE on our picture is 8. And we might as well do the third one since we're doing them all at once. And if we look at AB, it is 8. And DE is 12.8. So there's all 3 of the comparisons in this particular triangle. And we're going to set up 2 of them. And actually we only need to find side X, so we don't even need that third one in this case. We've got 6 over X equals 5 over 8. And once again, what we do to solve is we cross multiply. This times this times this. 6 times 8 equals 5x. And I know some of you already do. 6 times 8 is 48, and that's fine. Divided by 5 to get our value of x. And this one is going to give us a decimal. So 6 times 8 divided by 5 is 9.6. The key is, can you read the triangles to set up the proportion? That's the key. So as we flip our paper over, if we look at this triangle here, same idea. We've got triangle DEF is similar to triangle CBA, and we want to find the value of x. Just a slight bit different on this one because we've got 11x plus 11 for one of our sides. But if we start here, DE is 30. And CB is the 11x plus the 11. The other side length that we know is AB here, which is the second and the third values. So EF goes along with that. We can compare those. EF is in the second and the third place. It has a length of 21. And BA has a length of 77. And we're good at solving equations, and that's the good news, because when we cross multiply this, we end up with 30 times 77 equals 11x plus 11 times 21. And I usually like to write my 21 in front of that parentheses, but it doesn't make any difference. And in this particular case, it might be helpful to figure out, well, what's 30 times 77? It's 2,310. And regardless, if we write our 21 in front of the parentheses, if we write our 21 after the parentheses, we still need to take that 21 and distribute. So we're going to have 21 times 11x, well, 21 times 11 is 231. So this is 231x plus 231. And again, what we want to do here is we want to solve for x. So we're going to get the x by itself by subtracting 231 from both sides. Then we've got 23/10 minus 231, which gives us 2,079, equals 231x, and we want to solve for x. So we're going to divide both sides by 231. So 2,079 divided by 231 gives us 9. Example 4. In the diagram below, triangle MNQ is similar to MOP. We want to find the values of x and y. And on this particular problem, again, if you can read the setup, it should be helpful for you to set up the proportion. And what I mean by read the setup is knowing that MN is going to be proportional to MO. And NQ is going to be proportional to OP. And that MQ is proportional to MP. So as we take a look at this, MN has a length of 8. MO has a length of 12. It's the 8 for the MN, and it's the 4 for the NO, and 8 plus 4 is 12. So watch out what you're given in the triangle here. If we go to the next value here, NQ, NQ is 7, OP is Y, and since we're going back and we're looking at the setup of the similar triangles here, might as well do the third one, the third fraction here, which is going to be MQ. Well, MQ is 10, and then MP is 10 plus x. It's this length and that length. It's the whole length there. So watch out for that. Again, if you can read the similar triangle notation, it makes it simpler. And sometimes math is never simple. And I'll start with the 8 over 12 equals 7 over y. We're going to cross multiply. 8 times y equals 12 times 7. 8 times y is 12 times 7. And then we can divide both sides by 8. And we can type it in. 12 times 7 divided by 8. 10.5. But not only do we want to figure out y, we want to figure out what x is also. And we have everything set up here. And notice, we've got 8 over 12. That's a complete fraction. We don't have any variables in it. So let's use that one again. And then we need to figure out our x, which is our third fraction there, the 10 over the 10 plus x. We're still going to have to cross multiply, which means that we have to distribute. It's going to be 8 times 10 plus x equals 12 times 10. Some of you might skip that step. I'm all right with that. But remember to distribute. We get 80 plus 8x equals 120. we can subtract 80 from both sides. And when we do, we get 8x equals 40. And then when we divide both sides by 8, we end up with x equals 5. So a lot of algebra in working with the proportions. But as we get close to finishing on these last two, in the diagram below, figure ABCD is similar to figure EFGH. In this particular problem, measure of angle C is 70, and measure of angle G is 8x minus 18. We want to find the value of x. The thing about angles in similar figures is the angles don't change values. It's the sides that are proportional. The angles stay the same. So if we look up here, C is in the third position, and G is in the third position, so those two have the same value. You get 70 equals 8x minus 18. And again, we want to solve for x. So we're solving an equation to finish this problem. We're going to add 18 to both sides. We get 88 equals 8 times x. And we divide both sides by 8. So x equals 11. Finally, we've got a picture here, so that's helpful because we see these words. But it says, Michelle wanted to measure the height of her school's flagpole. She placed a mirror on the ground 48 feet from the flagpole, then walked backwards until she was able to see the top of the pole in the mirror. Her eyes were 5 feet above the ground, and she was 12 feet from the mirror. Using similar triangles, find the height of the flagpole to the nearest hundredth, that's 2 decimal points, of a foot. So this particular problem here, we don't have any triangles to revert back to. But since we do have similar triangles, let's set up our proportion here. The height here, her eyes 5 feet above the ground, is going to coincide with the height of the flagpole. So whatever we want to call the length of the flagpole here, maybe x. So we can say 5 over x, but stick with the triangles. Since I started with 5, I also have the distance away from the mirror is 12, and then the distance away from the mirror to the flagpole is 48. So we've got little triangle to big triangle. 5 is the little, x is the big. 12 is the little triangle, 48 is the big. And we can cross multiply to figure out our height. It's 5 times 48 equals 12 times x. Divide both sides by 12. And we can type it in to finish. Well, wrong thing. Five times 12. So 5 times 48 divided by 12 gives us 20. We didn't even need to round to the nearest hundred on this one. It's 20 feet tall.